right, good morning. If everybody would open up to page 17 in their notes packet, and I would like you to make sure that you're taking notes as we kind of go along and do this. I want to talk a little bit about the unit circle. So if you remember, the unit circle has essentially 5 main angle measures on the unit circle. So the first one would be at 0. And then remember, we would go 90 degrees, which is equivalent to pi over 2. Then we would go another 90 degrees, which is equivalent to pi. Then we would go another 90 degrees, and that would be 3 pi over 2. And we would go another 90 degrees, and we would be back at the beginning of 360, which is 2 pi. Now this should look familiar to you. We did do this last year, where, we put 0 here, here's 90, 180, 270, 360, okay? All right, so now you can page back and you can look at the unit circle, but hopefully at this point you have it memorized. And all I'm going to ask you is, we're doing a sine curve, right? So I just want to know, what is the sine of 0 degrees? Remember, sine is the y value, and so you should know that that y value is going to be at 0. So I'm going to put a dot there. Okay, next I'm going to ask you to just look from either the page in your packet or your brain. What is the sine of 90 degrees? And again, we want only the y value. So that would be 1. So what I'm going to do is, and it really doesn't matter, guys, what your y-axis is and how it's labeled. I'm going to go up 1, 2, 3, 4 boxes, and I'm going to make that a 1, which means 1, 2, 3, down 4 boxes, and I make that a -1. How many boxes you go up or down to spread out your 1, it doesn't matter. I'm just doing it because it'll make it look a little prettier. Okay. All right, so again, the sine of 90 is 1. So right here, I would say, okay, well, the sine at 90 degrees is 1. All right? So if you go through the rest of that unit circle, I know that the sine of 180 is 0. I know the sine of 270 is -1. And the sine of 360 is back at 0 again. Okay? So we connect all these dots, and if you remember from last year, it just goes like this, and then like that. Okay, so please make sure that you're drawing this in your notes packet. So what we call the behavior of the sine curve is, we start, finish, and in the middle, we are all at 0, all on the x-axis. In between our first 2 zeros, we go up to 1, and in between our second 2 zeros, we go down to 1. And that's the general behavior of a normal sine curve. Obviously, we are going to have changes where we may shift or whatever, but we'll deal with that later. Okay, so now, obviously, also, if I went out in this opposite direction, this being -2 pi, this one here would be -3 pi over 2, -pi, and -pi over 2. I'm not going to label all of those, but remember, this is always a continuous wave, so we would just kind of go in the opposite direction here if we were continuing this graph out. So it would look like that. Okay, so make sure you get that down. Now the same thing's going to hold if we're doing a cosine curve. So I'm going to go out 2 spaces on each, and I know that this is pi over 2, this is pi, this is 3 pi over 2, and this is 2 pi. Okay, and I'm going to go 1, 2, 3, 4 and put a 1, and 1, 2, 3, 4 and put a -1. Okay, if I'm going too fast and you want to get this all down, just pause me, do it, and turn me back on. All right, so I'm going to do the same thing. So cosine, now remember, when we're doing unit circle, cosine is the x value. So if I want the cosine here at 0, and actually I guess I really should label that 0, shouldn't I? 0. I know that the cosine of 0 is 1. And now I'm going to go to the cosine of 90. So I'm going to look at 90, look at its x value, and I see that it's 0. Again, we're looking at the unit circle. Cosine of pi is at -1. Cosine of 3 pi over 2 is 0. And the cosine of 2 pi is 1. Okay, now, don't draw this, don't connect those. This does not look like a parabola. So remember, just watch for a second. You're supposed to kind of flare and then flare again. So that's what it should look like. Okay? All right, so like I said, if you need to pause me to get this down, go ahead and pause me. This is review, so I'm going just a little bit quicker when it comes to this. Okay? All right. So I'm just also drawing the other side. It would just be a continuation. So just a couple of things that I think that make this a little bit easier that I taught my students last year in Algebra 2 is if we look just starting at 0 and we look at this portion of the graph right here, look at it. It kind of looks like, if you tilt your head to the right, it looks like an S, but just kind of flipped on its side, okay, and flip-flopped. So like I know this part, maybe would be down here and this part would be up here. But this looks like an S. The behavior of a sine curve is to start, middle, and finish on the midline or the x-axis. In between, we go up. In between, we go down. Cosine curve, if you look at this and tilt your head, maybe to the left, you'll see it kind of looks like a wonky little C. Cosine curve starts and finishes up. For the most part, not always though. Starts and finishes up. In the middle of this start and finish, look at what it does. It goes down to its minimum. And then between this maximum and this minimum, I hit the x-axis. And between this minimum and this maximum, I hit the x-axis. Okay, starts and finishes up, middle is down low, and in between is the x-axis. Okay, make sure you're writing this down. All right, so if you turn the page, we can look over here again. Here's our normal sine curve, starts, middles, and finishes, so to speak. Okay, right on the x-axis, we go up to its maximum in between, down to its minimum. Same thing with cosine, start and finish high, middle is low, zeros in between. Okay, so if you remember, the period stands for how long it takes for one full cycle, horizontal length of one complete cycle. So if you look at this, one cycle is done right here, and that is at 2 pi. So that graph has a period of 2 pi. Okay, if you look at the cosine curve, see that it starts at 0 and it finishes at 2 pi. So again, one cycle of a cosine curve has a period of 2 pi. So how long it takes to get one full curve is the period. You need to know that. Make sure you star that, highlight it, memorize it, okay? All right, now frequency is the number of curves every 2 pi units. Basically what that means is how many curves from 0 to 2 pi. So if I look here, my frequency is 1. I have one curve from 0 to 2 pi. This is not one curve and then here's the other for a total of 2. This up and down is one full curve, okay? So your frequency here is 1. The same thing holds for this cosine curve. We start high and finish high. That is one full curve from 0 to 2 pi, okay? So your frequency for this one is also 1. Frequency again, how many curves do you see from 0 to 2 pi? I see 1. How many curves do I see from 0 to 2 pi? I see 1. Okay? So that's what you do. Make sure you know the difference between period and frequency. Some kids get confused. If you memorize the sentence, you will never forget it. Okay? All right, now we also use these rules. They're very important. Star them, highlight them, circle them, whatever. But they'll make more sense when we start going through some examples. But just notice that these two words are interchangeable. The period is 2 pi over the frequency, or the frequency is 2 pi over the period. Okay, so these can get flip-flopped right here. So that, you really only needed to memorize one of them because the other one is just the flip. When I say the flip, I shouldn't say that. Where frequency goes to the period spot and the period comes down here to the frequency spot, like what you see right here. Okay? All right, so now turn to page 19. And again, this is all review. I actually cut and pasted a lot of this from your Algebra 2 last year. So it says, oops, hold on, let me get rid of that. I thought I had my pointer on. What effects does a value A have on a graph? A is that number all the way in front. That's your amplitude. That's how high your graph is. So if you look at this, my amplitude is a 1. I can even look here. I know I go down to -1, but this distance is still a 1. Okay? And the same thing here. We always look at the distance from the midline up to the top or the midline down to the bottom. That's still a distance of 1. So both of these graphs have amplitudes of 1. This graph here, if we look at this one, has an amplitude of 2. So instead of having a high point of 1 like we have here, this graph is going to be the same exact as this one. The only thing is it's going to stretch up higher, and we're going to be up here, and then we're going to be down here, okay? So why don't you take a minute, graph it, and then pause me, graph it, and then turn back on, and let's see what we get. Okay, so I always think a good rule of thumb is to label those plot those 5 points, like you can see on my graph first. Don't just try to sketch it without doing that, because most times it doesn't look very pretty. Okay, so all I'm going to do is I am going to connect those 5 dots now, and you should see that it looks like this. Okay, so the only difference is I want you to take note. I went every other box is 1 unit, so this is -2, and every other box, that's +2. Okay? All right, so we're going to do the same thing with the next one, but it's a cosine curve, and look at its amplitude. Its amplitude is 1/2, so we're not going up to 1, we're going up to 1/2. So maybe, like, for example, I could make this a 1, and I could make this a -1. And I know I'm going to look up here, look at my cosine curve. It starts up at its maximum, and it finishes at its maximum. Well, its maximum here is 1/2. So I am just going to go right there at 1/2, and I am going to go right here at 1/2. Oops, that didn't work, did it? There we go. Well, it's supposed to be on the box, but you get the idea. All right, and then remember the behavior of a cosine curve, smack dab in the middle, we're going down to its minimum. So smack dab in the middle would be a pi, and I'm going down to its minimum, which would be 1/2. Should be right there. Okay, and then in between, I go to the x-axis, put a dot, x-axis, put a dot. All righty? And then we're just going to connect those 5. Try to make that flare the best you can. And there we go. Sorry, that looks a little icky, but you get the general gist. Okay. Now let's look at the one below it. The one below it has a negative. So don't freak out. Do you see that the number in front of here is a 1? Granted, it's negative, but it's a 1, just like this one. So remember, all the negative is going to do is it's going to flip it. So instead of going up to 1, I'm going to be going down to 1. So let me just put some, that's going to be 1. And this will be, I have to write it underneath, -1. So in other words, here's my first point. And remember, middle is always on 0, and the end is always at 0. Okay. And then in between, instead of going up 1, I'm going to go down 1. And instead of going down 1, in between these two guys, I'm going to go up 1. Okay, so that's going to go right there. And then all I'm going to do is I am going to connect those. So here we go. Okay, so why don't you take a minute and do this last one, y equals -2 cosine x. Pause me, try it out, and then check your answers. All right, there are your 5 points. The negative flips it, and then There's your graph. All right, so if we turn the page, now let's look at what it says at the top of the page here. What effect does the value of B have on the graph? This B, I keep thinking I have my pointer on and I don't. This B right here, if you remember, it stands for the frequency. How many curves you see from 0 to 2 pi. Okay, so here I'm going to see 2 curves from 0 to 2 pi. 2 of these from 0 to 2 pi. So this is 1, then I'm going to need another. So if I need to get 2 curves from 0 to 2 pi, how long will it take to get 1 curve? So let me repeat that again. If I'm going to have 2 curves, 2 of these little sideways flippy S's from 0 to 2 pi, then 1 curve should take me from 0 to 1 pi. So my beginning, here, let me do this, here we go. So my beginning, my end, and my middle of my first curve should be right there. Okay? Now I'm just going to go up 3 boxes, and I'm going to let that be 1, and I'm going to go down 3 boxes and let that be -1. Okay? Now it's a normal sine curve, so in other words, its amplitude right here is a 1. So that means that I'm just going to go up 1 in the middle, which is 1.5 boxes right there. Okay, and down 1 in the middle, and that's also 1.5 boxes. Now, what do I mean by 1.5 boxes? You have 3 boxes here, 1, 2, 3. In between 0 to 2 pi. So you have to go in the middle of that, which is 1.5, and then up. Same thing here, 1, 2, 3, go in the middle, so that's 1.5, and then go down and put that dot there. Okay? All right, and now we're going to connect those 5 dots. There's your first curve. We need to have 2 curves from 0 to 2 pi. So there's 1 curve. Now I get to draw another one. So let's do the dots again. So here's my beginning, which is already there. Here's my end, and here's my middle. Go in 1.5 boxes, and then go up to 1. Go in 1.5 boxes, and go down to 1. Oops, sorry, that's a little off, but my point isn't very pointy. Okay, so then we're going to go bum, 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 and there we go. So we have 2 sine curves from 0 to 2 pi. All right, now if we look at this next one, we have 2 cosine curves from 0 to 2 pi. Why don't you pause the video and try that out and see how you do. All right, so there's your first 5 dots. Make sure that you flare, and that's what it should look like. Okay, all right, now let's do the next 5 dots. Okay, there's your next 5 dots, and then we're going to connect those. And it should look like that. And there's cosine 2x. All right, now let's look down at the next one. Now that's a half of a sine curve. So let's be a little careful here, because this up here is a full sine curve. So a half would just be this part right here. That's all we want to see. So we want to start at 0, finish at 0, and go up in the middle. Okay, and that's from 0 to 2 pi. So our first point is going to be here. We're going to end here, and we're going, end here, there we go. And in the middle, we're going to go up to 1. So just like that. So it's going to get stretched out a little bit, but that's what it'll look like. Okay? All right. Make sure you're copying this. Let's look at the cosine curve. This is a full cosine curve. This one wants a half of a cosine curve. So if we were to cut this thing in half, this is where we would cut it. So look, follow my green arrow. We're going to be going and drawing just that part right there. So we're going to start high, 0 in the middle, down low. Okay? All right. So we're going to start, I'm going to make this a 1 again. So there's my first dot. Okay. We're going to finish, now remember we have to go out to 2 pi, so we're going to finish all the way down there, and then in the middle, we're at the x-axis. Now you have to, please be careful with this. It's got to look like this, so it's going to kind of curve and then curve. We don't draw a straight line. We don't just go root. That would not be cool. Okay, so let's try to curve and curve, and that's what it would look like. All right, so if you would turn to page 21 and answer the amplitude and the frequency. And this is what you should have. Okay, so your amplitude is the number in front, your frequency is the number that's right before the x. Now, as far as the period, this is where we're going to use that rule that we had on the other page. So period is essentially 2 pi over the frequency, and this frequency is 1/2. Okay, so remember that that's 2 pi, we can keep change flip, times 2 over 1. All right, so when all is said and done, the period is 4 pi. All right, so what does all this mean? This means we're going to have one full curve by the time we get to 4 pi. Okay, and this means we're going to have a half of a curve from 0 to 2 pi. Okay, I'm going to ignore the domain for a minute. Let's just go with what we're really familiar with, okay? So that's what I would do, okay? Now, I know the amplitude is going to be 3, and I know I'm only going to see half of a sine curve. So sometimes, you know what, guys, what might be beneficial is to just draw a sketch. Well, I know a half a sine curve looks like that. Okay, I know the amplitude is going to be 3, and a half a sine curve, meaning I'm going to end there at 2 pi. So now I can take this right here, and I can transfer it up over to here. Okay, it kind of gives me a better idea of where to put my points. So I see that I'm going to have a point right here then, and at 2 pi, I'm going to end there, and at pi, I'm going all the way up to 3. So it'll look like that. Okay, and if you look at that, the amplitude is 3, and I have a half of a sine curve from 0 to 2 pi. And that's what this 1/2 means. The frequency is how many curves from 0 to 2 pi. Okay, now let's address the domain that they gave us right here. So what they want us doing is they want us drawing the graph from negative 2 pi all the way up to positive 2 pi. Well, I only have from 0 to 2 pi, so I need more over here. So remember, this is a wave, so I'm going to continue going like this and then like that. Okay, so why don't you see if you can draw that left-hand side? Pause me and do that. Okay, so that's what I have so far. Now, I do understand that the domain is from 0 to pi. Again, maybe you want to ignore that. Please, though, use a pencil. And I know a cosine curve when I'm working on a cosine curve. I know that I start up, I finish up, and in the middle, which is at pi, I go down to its minimum. And then in between, I have a 0 and another 0. Okay, another 0, there we go. All right, now I'm going to do this two-toned. So this is what I mean by that. So watch, the normal cosine curve would go like this, right? And then it would come up the other side like that. Okay, now the reason why I did that two-toned is because I see that I'm only going to pi, which is right here. Now, if you guys drew this whole thing in one color, that's totally fine. Guess what? Just erase this part right here that I have in red. So the answer is really just from 0, 4 down to pi over 2, 0, and then down to pi, -4. Only this part right here is your answer, okay, because of that domain.